Look at problems E and F, but let's do that on the next page because we're running out of room. Okay, for problem E, let's start there. Let's see what we've got. We have R to the 1/5, S to the 2/3 to the 15th over R squared. So because there are parentheses around everything on top and the exponents on the outside, what that means is that we need to take that exponent of 15 and distribute it or multiply it to everything on the inside. So the first thing that we would start off by doing is multiplying the 15 by the 1/5. Remember that 15 is 15 over 1. So multiplying the tops and bottoms, we get 15 times 1 on the top will get us, let's see, a 15 on the top. And on the bottom of our fraction, we'll get a 5 times 1 on the bottom, which is 5. Well, notice that that exponent, 15 over 5, actually reduces to R to the, well, 15 divided by 5 is 3. Problem, we still have to multiply the 15 times the 2/3 here. We're distributing it to everything. Well, let's keep on going. This is an S term. So let's see what happens with our S term here. Well, multiplying, let's see, we've got to multiply the tops first, which is the 2 times 15, which is 30 on top. And on the bottoms, we've got a 3 times 1, which is 3. Well, 30 divided by 3 is just going to be 10. So that'll be S to the 10th. The one term that we have not even touched is the denominator, the R squared. So we're just going to leave that as is for a little bit, R squared and an R squared here. Now the question is, now that the top has been distributed and the bottom was left alone, is there anything else we can do? Well, there is, once everything is simplified like this, is we can reduce the R cubed over the R squared because they have the same base. So, because they have the same base, they can be combined to another R. The question is, what do you do to the two exponents? We've got a cubed and a squared. Well, when we're dividing, what do we do to exponents? We subtract. Well, 3 minus 2 is going to give us an R to the first power, or 1. We still have our S to the 10th. Now remember, when an exponent is a 1, on a variable, we don't have to write it. So I can just hide that 1 and rewrite it as just an R, an S to the 10th power. That is our final answer. Let's look at F. On F again, we've got, let's see, P to the 3rd raised to the 1/4 over P to the 5/4 to the 2nd. Now on top, again, let's go ahead and simplify that. We are, because of the parentheses, multiplying the exponents. Well, if I want to multiply fractions, I need to have them both as fractions. So the 3 is 3 over 1, and I'll multiply tops and multiply bottoms. So this will give me P to the, well, multiplying the tops, I've got a 3 times 1, which is 3. And multiplying the bottoms, I have a 1 times 4, which is 4. Now the question is, what's going to happen on the denominator? I need to do the same thing. I should have another P on my denominator. But on the denominators, I am looking at, let's see, a 5/4 times a 2, or 2 over 1. Multiplying the two tops, I get a 5 times 2 is 10. Okay, and on the bottom I get a 4 times 1, which is 4. Now notice, you do get 10/4 as your exponent, and you might think about reducing that, but I actually don't want to. The reason why is if you kind of zoom out and look at this whole problem, the p's still match, so they are the same base. So you can get away with just doing what to the exponents? Well, when you're dividing, you can subtract the exponents, which is a good thing that I didn't reduce the 10/4 because now I already have a common denominator. So when I go to subtract the exponents, 3/4 minus 10/4 will give me a negative 7/4. So what that gives me right now is it tells me right now I have a p, and when I divide, I'll subtract the exponents, I'll get a negative 7/4. Now this answer is almost perfect. The problem is what? The problem is you can't leave your answer with a negative exponent. So how do we get rid of the negative exponent? Remember, we get rid of the negative exponent by dropping it to the denominator, and the exponent will go from being a negative 7/4 to being a positive 7/4. And then what's going to be on top is your hidden 1. So that's our final answer, 1 over p to the 7/4. Let's look at problem G. In problem G, let's see, we've got x to the 1/3 times x to the negative 2/3 times x to the 1/6 over x to the negative 1/6 cubed. Well, let's deal with one thing at a time. We have parentheses on the denominator, so let's deal with that first, which means I'm going to be multiplying exponents. So that would give me x to the negative. Well, remember that 3 is 3/1.